in less than 10 minutes, I hope, I'm going to show you what volts, amps and watts are, why they matter, and what on earth they have to do with a water gun and a hose. G'day, I'm Rosie. I live full-time in my van with my red dog Tilly. And I have designed my electrical system from the ground up twice over now. I want to help you do exactly the same. This is the first video in the Build Your Own Electrical System series, so make sure you subscribe to never miss a video. Before we dive in though, just remember, I'm a random chick on the internet, self-taught. This is just for your information. Please do your own research. I am not an expert. We can liken an electrical circuit to a hose. Now, an electrical circuit is a closed loop of a conductor, for example, like copper, in an electrical wire. For a hose to work as intended, you need water, but without pressure, nothing's going to come out. So you turn the tap on to give some pressure, out comes the water. In an electrical circuit, instead of water, we have electrons that are flowing through. This is what we call voltage. The pressure in the electrical circuit is the voltage. You might have heard of 12 volt, 24 volt, 240 volt, 120 volt. That's the pressure within the circuit. Or think back to the hose. The pressure that lets the water out, lets the water flow, or in the circuit, lets the electrons flow. So that pressure is pushing the water out, or if we think about it in terms of an electrical circuit, it's pushing those electrons around. Voltage really matters. Not only is it an essential part of a circuit, but different areas in the world have different nominal voltages, okay? So if you were to buy a microwave in the US that was only designed to be run on 120 volts, and you brought it to Australia where it's 230 volts, you would have a problem. There would be excess heat and potentially a fire. So you don't want to muck around with electricity. Voltage is important. Let's move on to amps, and we are going to continue with our garden hose analogy. So if the voltage is the pressure of the water going through the hose, the amps are how much water is flowing through at a given point in time. How much water is going past? Or if we're going to use real terms, how many electrons are going past a certain point in the circuit at a given point in time? So essentially it's like the flow rate. The flow rate of the water through the hose or the flow rate of the electrons. Now, if you have bought a battery or batteries for your off-grid system already, or maybe you're researching them, you will have noticed that they all have an amp hour rating listed on it. So what the hell are amp hours? Amp hours tell us how many amps, in our example using a battery, how many amps a battery can provide for exactly 1 hour. That's what amp hours are. So if you were to buy a 200 amp hour battery, it could provide 200 amp hours for a period of 1 hour, at least if the manufacturer is telling the truth. That will keep it simple, right? Now, please subscribe if you want to hear why I strongly believe that we should stop talking about batteries and amp hours and be using watt hours instead. I'm not going to go down that tangent right now, but subscribe because it's important. If this is feeling like information overload, which it probably is, don't stress. I've put together a PDF. You can download it for free. Link is in the description and I'll chuck it in the comments as well. Let's talk about watts, and I want to use a water gun to help explain that. I don't know where I squirted that. Whoops. If you think of a water gun, the opening is very narrow. There's a lot of pressure. That's the voltage. Think about a hose. The opening's really wide. There's low pressure. Again, pressure is voltage. Let's think about amps, which is the flow of electrons or the flow of water. The flow of water in this water gun is going to be a lot less than the flow of water in the hose. But what is really cool is that the power, that the water gun and the hose produce is exactly the same. That is exactly what watts are. It is the power that the electrical circuit is either generating or using. As simple as that. And it's at a given point in time. You could liken it to a speedo on your car. The speedo, or speedometer if you want to be really proper, tells us how fast the car is travelling at a point in time. At any moment, the speedo could have a different reading depending on where your foot is on the accelerator. If you think about the hose, it depends on how open the tap is. You're having a shower. Your shower head, if you've got the tap open on full ball, could be using 8 litres per minute, for example. Or if you've only got the tap turned on a little bit, maybe it's only using 4 litres per minute. So it can change. Pretty simple, right? That's what watts are. But think of your electricity bill for a minute. It's not written in watts, it's written in kilowatts. And actually, it's not kilowatts, it's kilowatt hours. So we're going to talk about it in terms of watt hours, but same. 1,000 watt hours is 1 kilowatt hour. Okay? So watt hours. What on earth is a watt hour? Watt hours are when energy comes into play. It tells us how much power has been used or generated over a period of time. So if I had my hose filling up a bucket, how much water is in that bucket after I've been filling it for 10 minutes? Not the flow rate of the water that's going through, but how much water do I end up with after the 10 minutes, or after for watt hours, it's after 1 hour. What do I end up with in 1 hour's time? If we go back to a car example, because I brought that up before, instead of your speedo, which is a specific point in time, it would be like your odometer. How far have you travelled at the end of your journey? That's what a watt hour is. How much power, or watts, has been used over a period of 1 hour. Let's use like an everyday example, okay? So let's think of a shower head. It might have a flow rate of 8 litres per minute. That would be the amperage, or the amps. It's the flow rate. The watt hours would be how much water would I have used at the end of my 6-minute shower. And that would be 48 litres. What do you end with it? How much have you used or generated at the end of that period of time? That's watt hours. The equation that brings all this theory together is Watt's law. Everyone talks about Ohm's law, yes, but Ohm's law doesn't actually have watts in it. So we're talking about Watt's law. Now, Watt's law says that watts are equal to volts multiplied by amps. Simple. And you can rearrange it using algebra to figure out whatever you want. So let's say I have an 800 watt microwave. Mine's older, it's not super powerful. I'm in Australia, 230 volt nominal voltage right here. So using Watt's law, I would go 800 watts divided by 230 volts, and that would give me 3.5 amps. Okay. What if we had this 800 watt microwave in the US designed to be used on 120 volt? How many amps would that draw? Let's see. 800 watts divided by 120 volts equals 6.7 amps. It is different, just like the water gun and the hose. The amps, or the flow rate, are different. So remember, the water gun is higher pressure, lower flow rate, so higher voltage, lower amps. The hose is lower voltage, higher amps, or the flow rate. So Australia would be the water gun, and the US would be the hose, if that makes sense. Now, this video is just, I've thrown so much at you. I hope I haven't lost you. I wanted to post this because it's just a good foundation to understand the basics. Knowing Watt's law will allow you to calculate the size of the wiring you need, the size of the fuses you need, the type of fuses, the inverter you're going to need, the solar panels you're going to need, the charge controllers you're going to need, everything. Next video, I'm going to be showing you how to size your wires and your fuses using Watt's law. It's not to be missed. Let me know, have I confused you even more, or do you understand volts, amps and watts a little bit better? Let me know in the comments, drop me a like, and if you feel like it, buy me a chocky milk.